Ready? Welcome to Tag Day 7. The focus of today's lesson is 7.5c, so similar figures and scale factor, and we will be stamping our understanding of two different terms, scale and scale factor. So we know that a scale is a ratio that compares the measurements of a scale drawing to the actual figure. So scale, write this down, is a ratio that compares drawing to actual, right? So this is just a shorthand definition. So as an example, let's look at this next problem. The distance between two cities on a map is 3.5 centimeters. The map uses a scale in which 1 centimeter represents 20 kilometers. What is the actual distance between these two cities in kilometers? So let's first think to ourselves, what is the scale? Does the problem tell us? Well, it says that for every 1 centimeter on the map, that it represents 20 kilometers. So let me circle that. And so that represents 20 kilometers in real life, right? This is a real life measurement. I mean, not that the other one isn't, it's just we use 20 kilometers as a distance on a map that we would actually walk or drive. And so we could represent this scale as a ratio. So 1 centimeter represents 20 kilometers. So let's go ahead and write that. So this ratio then becomes very useful because it can help us find unknown information. So to find the actual distance between these two cities, I can create a set of equivalent ratios, also called a proportion. So remember that we set up our proportion with what no need. So let me go ahead and just get that situated on our paper, the way that we're used to writing it. What no need. Remember, we set up those three proportions, first with our label, which we have centimeters and kilometers. And then let's include that ratio we just wrote, right? We just took the labels and we just put them to the side so that we can make things a little bit more organized and neat. And so the problem also told me that the distance between two cities on a map is 3.5 centimeters. So where am I going to put that? Well, on the top where the centimeters go. So here is the top open available space. So that's 3.5 centimeters. And the question is saying, what is the actual distance between these two cities in kilometers? So the kilometers is missing. Therefore, I'm going to use K as our variable. So we have created our proportion. So if we solve this proportion, then we will find our answer. So we can go ahead and solve this proportion. How do we solve proportions again? Using cross multiplying and dividing. So I can multiply 3.5 times 20. I see there's one number behind the decimal point, so there needs to be one number behind the decimal point here. So we get 70 equals 1 times k. And so we know that dividing any number by 1 leaves itself, but we just want to make sure we finish the cross multiplying and dividing, and we get 70. So 70 what? What does k represent again? Kilometers. So let's go ahead and label that. All right, so 70 kilometers. So since we now know what a scale is, let's now think about what is a scale factor. So for our purposes, the term scale factor, let's get ready to write this down. Scale factor has two meanings. So in general, a scale factor is the multiplicative relationship between two proportional sets of data. So in other words, it's the number we multiply one data set to get another. So let's add this to our notes as well. So for example, in the equation y equals 2x, so let me just write this down as well, we are multiplying every x by 2 to get y. So y equals 2x, right? We would multiply every x value to get y. Therefore, 2 is our scale factor, right? Because we are multiplying one number by 2 to get a different number. So we call it scale factor. So we can go ahead and use this version or this concept using our problem that we just did. And so I can make a table, right? A table with the actual figure, right, versus the map. So, the actual and then the map. Okay, and so in similar figures, the term scale factor has a more specific meaning. It's the number we use to represent the multiplicative relationship from the actual figure to the scaled figure. And so we're going to look at that example above and draw out a table to represent the relationship. And so here we go. If I look at the actual amount they gave us of 20 kilometers representing 1 centimeter on the map, I can follow this proportional relationship throughout the table so that I can begin reasoning out the answer to my question. So if I had another centimeter, if I added another centimeter, that would be 2. So I would have to add another 20 kilometers to get 40. And the same thing with, I don't know what I just did. Whoopsies. So if I add another 1 centimeter to my table, then I would have to add another 20 kilometers to my actual side of the map. And then I get 4 centimeters, and then I get 80 kilometers. Now, I don't want 4 centimeters. I don't want 3 centimeters. I actually want 3.5. So I'm going to add half of a centimeter, right, to get from 3 to 3.5. So what do you think we would have to do if we added, instead of 1 whole centimeter, we had to add half a centimeter? So instead of adding 20 kilometers, how many kilometers do you think we have to add? Well, half of that. So that would be 10 kilometers. So that would be 70 kilometers. And sure enough, that matches what we got in our answer using our proportion method. So here is a ratio table that uses our scale factor, right, that we can then use to multiply to get from the actual figure to the scale figure. And we would call that scale factor we would call that number a scale factor. So if you notice here, 4 to 80 is times 20, 2 to 40 is times 20, and 3.5 to 70 is also times 20. So that would be our scale factor. So let's just stamp that for a pair of similar figures, a scale factor is the multiplicative relationship between the actual figure and the scale figure. And we can use a proportion with what no need, or we can use a ratio table to set up our proportional relationships and solve. Let's practice some more on our own.